And then we'll keep going. So we are finishing 3-4 today, and we had our calculators out because we were doing these logs. Again, if you do it in the calculator, if you go ahead and just press, I think it's math, and then I think it's go all the way down to A, you'll have an option to enter something for base and enter something for like the actual log that we're doing. And if you didn't have this, I think we went over this at the end of class yesterday, so like there's a couple of us in here who have older calculators. You're just gonna have to do log of the main, the big number, divided by log of the base. And so this is what all of our answers should be as we go through. So the first one. Okay, yeah. Let's see, the first one was 1.2619, this one was 0.3263. We've got 1.2323. 1.7354. And then negative 2.3532. And 6.4919. Did anyone have any trouble getting any of these numbers? Nope, good, because there'll be questions like this on the test, easy, gimme, just plug it in your calculator and go. So I just want to make sure that you know how to do this. Once you have that done, let's flip our paper over. We just got 2 word problems to do. And I know word problems aren't our favorite, but these are just 2 plug-in chunks. So we're just gonna plug them in, plug in some numbers, solve them from the calculator. So if we go to 4A, it's talking about light intensity. And I know word problems again can be scary, but this one gives us an equation and we're just gonna plug a number in. So we don't even have to fully understand what's going on in this word problem. The relationship between I, the intensity of light in lumens at depth X of feet in Lake Superior is given by this equation. And then it says, what's the intensity at a depth of 10 feet? Where is 10 gonna go into my equation? X, very good, why?
Because it tells you that.
X is feet, that's really all I want. X is feet, that's all that really matters. So we're gonna plug 10 in for X, and then we're gonna solve accordingly, okay? So I've got log of I divided by 12 equals negative 0.0125 times 10. Okay, so it's good that we already had our calculators out because we're gonna keep using them. I'm gonna do that negative 0.0125 times 10, which would just move the decimal place over 1. So I get log of I over 12 equals negative 0.125. Then at this state, we can't solve this in its log form, so that means we need to put it in our exponential form. What would my base be here? What would my base be? 10. My iPad always messes up. There we go. Base would be 10. And then I'm gonna log roll it. So I'm gonna roll and I'm gonna go 10 raised to that negative 0.125 equals I over 12. 10 raised to the negative 0.125 equals I over 12. While that's ugly, you can plug that into the calculator and we can solve that. 10 raised to the negative 0.125. And I'm just gonna round that to 7.75 just so I don't have to write a bunch of stuff. And that's equal to I over 12. So how do I get I by itself? Multiply by 12. And even though I rounded on my paper, I'm just gonna have left that in my calculator. So I'm just gonna press times 12 so I can get the most exact answer. And I get I equals 8.9987. Well, that basically is 9. We'll just round it up to 9. I equals 9, and my unit here is in lumens.
What is lumens?
It is a measure of light. Don't ask me any more questions. Chase,
I was able to finally do like my graphic calculator.
did you graph it?
Yeah.
Great, that works. That is also fair to do. What happens is, since we've been practicing doing the log roll, I just did the log roll to finish. But you're telling me that you stopped here and you graphed this as your Y1 and you graphed this as your Y2?
Yeah, and then I like found the exit.
Yeah, great, that works. Mhm. So as Chase is kind of showing to us, there's lots of ways that we can find the answer to these problems. Okay, let's go to the next one. This is another one of those kind of plug and chugs. This time we're talking about the Richter scale, about earthquakes. The magnitude R of an earthquake is based on the features of an associated seismic wave, and it's measured by this equation. So again, we're really lucky, we feel good because we don't have to write the equation, they gave us one. And it says where A is the amplitude, T is the period, and B accounts for the weakening of seismic wave due to the distance from the epicenter. And it says compute the earthquake magnitude for each set of values. All we're gonna do is plug in the number for A, the number for T, and the number for B, and put it into our calculator. It sounds a lot more difficult than what it's actually gonna be. So for this first one, instead of writing A, we'll say R is equal to log of 250 divided by 2. That's my T, and then B is at plus 4.25. So log of 250 divided by 2. I'm gonna put that just directly into the calculator. I'm not even gonna simplify, I'm not gonna do anything ahead. I'm just gonna press log 250 divided by 2, and then plus 4.25. I get my answer. 6.35. Let's round it 2 places after the decimal. And that's magnitude, so I'm just gonna write 6.35 magnitude. Can you do the exact same thing for letter B? Plug and chug again. So I've got 300 divided by 4 plus 3.5. .38 magnitude on the second one. All right, we doing okay? Okay, at this point, we have finished 3.4, so that homework is due next time I see you, which will not be until Tuesday now. So I will see you on Tuesday, so this homework is due on Tuesday. Okay, we're gonna get into 3.5, we're gonna jump around a little bit. Basically just a map of what we're gonna do. We'll do this first little part right here, all the way up to G. We'll actually keep going. I think we finished all of number 1, but we skip number 2, and then we'll do the first few of number 3. It looks like a lot, but I promise it'll move pretty fast, okay? Yep. Again, I've given us 2 days to work on this, so I actually might have some practice problems that we're gonna do on Tuesday when we come back. Once we finish these notes, we might even have time to do a few more practice. So we're just doing some more solving exponential and logarithmic equations using each other. This first part says solve no calculator. It just means don't put it in your calculator. We're just gonna solve it by hand. If we need to use a calculator to see like 2 to what power is something, we can use that. But I'm gonna just get rid of my calculator for the time being, okay? Now, the first few problems are actually super similar to what we have done before, okay? So the first one, it says 2 raised to the x equals 8. Well, what number would that be? 3, very good. Now, if you forget, you can always do 2 to the x equals, we know 8 is 2 to the 3rd, and because their base is the same, then that means I'm gonna set their exponents equal to each other. You do not necessarily need that step if you just know 2 to the 3rd equals 8, okay? We're gonna keep using this concept, but we're gonna kind of build in intensity and complexity as we go. Letter B, I've got 3 times 4 raised to the x. I'm gonna get rid of that 3 by dividing it from both sides. You want it to just be a number raised to a power equals everything else. So we're gonna get rid of that 3 by dividing it from both sides. So 4 to the x is going to be equal to 16. And that's gonna be 2. Very good. X equals 2. Just to keep what I was doing, 4 to the x equals 4 squared, so x equals 2. Everyone doing okay so far? All right, let's look at letter 3, letter C. Now, in this case, there's no number that I can raise or no like whole number that I can raise 4 to get 8. So let's break it down so that they have the same base. Can I write 4 and 8 as some number raised to a power? Yes, 4 is what to what power? 2 to the second, very good. So I can rewrite 4 as 2 to the second. It's like 2 to the second raised to the x. And do you remember how we combine these numbers when we were taking a power to a power? Multiply them, good. So that would just go to 2x. 2 raised to the 2x. And then 8 is 2 raised to what power? 3, good. Now, since my bases are the same, we get to set our exponents equal to each other. So we'll say 2x equals 3. And then we can solve easily for x now. Divide by 2, x equals 3 halves. Okay, doing all right? All right, we're kind of at the point that we're gonna do a lot of the same stuff. So if you're bored by following at my pace, go ahead and try it on your own. But I do think we could use a little bit more walking through. So I'm just gonna continue to walk through with you. Does that sound good? Okay. All right, what should I do first on this next one? Divide by 3, awesome, get rid of that 3. So I get 4 raised to the 2x equals 32. Okay. Can we raise 4 to some power to equal 32?
Yeah.
I don't know if we can. No, I mean, we will, technically, it's a fraction, but we can't think of a whole number. So can we raise 4 and 32 to a number that's the same base?
2.
Yeah, 2. So 4 is 2 squared. So if I rewrite 4 raised to the 2x, that's gonna be 2 raised to what power? 4x, very good. We took 4 and made it 2 squared. And then I took the exponent and raised the power to a power. And we multiplied it. Now 32 is gonna be 2 to what power? 5. If you don't know, you can use your calculator and do 2 to the 3rd, 2 to the 4th, 2 to the 5th, as long as it takes. We are gonna do it, I think, enough of these that some of these will start sticking in your head. You'll be like, oh, we've done that one before, it's just 5.
Wait, how do you get 5?
If you put 2 to the 5th in your calculator, that's what you get. Also, I know that, you can think of this a couple different ways. 34 or 32 is 4 times 8, right? And how many 2's make up 4? And how many 2's make up 8? 3. So 1, 2, 3, 4, 5 2's together make up 32. You also could just sit and be like, okay, I know 2 squared is 4, and then 4 times 2 is 2 to the 3rd, that's 8, and then times 2 again is 16, and then times 2 again is 32. All right, now I've got the base the same, so I can set my exponents equal to each other. So 4x equals 5. X is gonna equal 5. Doing okay? All right, let's keep moving. Letter E, what do I do first? Mm-hmm. 5 raised to the x over 3 equals 125. Let me get a common base. I think 5 is a good one. So I'm gonna keep my 5x divided by 3 on the left side. What's the right side gonna be? 5 to the 3rd, very good. Once you have the bases the same, then we just set our exponents equal. X over 3 equals 3. How do I solve for x? Multiply by 3. Okay. All right, let's keep moving. Anybody have any questions yet? Next one, what should I do first on letter F? Divide by 2, good, so I get 9 raised to the x plus 3 equals 27. Can we do 9 to some power equals 27? Mhm. Can we get like bases with 9 and 27? Yeah, what is it? 3? What's my exponent gonna be on this left side now?
Three. X plus five. Really three squared, and then where this is.
We can think of it as 3 squared and then x plus 3. So we're gonna multiply, 9 is 3 squared, and then we're gonna multiply that by the exponent that's currently here. And I'm actually gonna leave it like this, we'll simplify that in a second. And then 27 is the same thing as 3 to what power? Good, do the third. Now that I have my bases the same, I'm gonna set my exponents equal to each other. And in this step, I am gonna distribute, instead of keeping it as 2x plus 3, I'm gonna make it 2x plus 6. And I'm gonna say that that equals 3. Is everybody okay with that? Okay, minus that 6 from both sides, 2x equals -3, and then we'll divide by 2 and x equals -3. All right, let me do one more with you, and then I'll have you try 2 like this on your own. This one's a little funny because it's a fraction, so I thought we should do this one together. What do I do first? Divide. Now, as tempted as you may be to go put this in your calculator, I want you to leave it like a fraction, okay? So I've got 1/2 raised to the x over 4. And then what is 9 over 36? How do I simplify that fraction? 1 over 4, good. Okay. Now, again, we want to get same bases. You could write the 1/4 as 1/2, but I think it's just as easy and maybe better for our brains if we made them both have a base of 2. So if I went from 1/2 to have a base of 2, what would that change about my exponent? What would my new exponent be? -1, good, so it would be negative x over 4. Because that negative makes my fraction flip. Similarly, how can I write 1/4 as 2 raised to some number? Negative what? It would be, I would write it as 2 raised to some power, that gives me 1/4, -2. The negative makes it flip, so that's why it's a fraction, and then this 2 makes it squared. So we know that 2 squared is just 4, but because I don't want 4, I want 1 over 4, I have to have that negative exponent to flip it. And I've got negatives on both of these, but it's gonna be okay because they'll cancel out. Now, since the bases are the same, we can set our exponents equal to each other. Negative x over 4 equals -2. And we'll just multiply by -4 on both sides. So I get x equals 8. Right. What'd you say? Are you found now? There's one like this on the next side. The next one's a lot like this, so I'm gonna try and let you guys try the next 2 on your own, okay? I will do them on the board so you can see them, but I'm gonna be quiet while I do them. All right, I've got that letter H done. If you want to check in, make sure you're doing okay with it. Anybody questions on this one in particular? Okay, I'll leave it up on the board for a minute, but if you're good on letter H, I want you to jump over to letter I, see if you can do that one. No, I'm gonna do letter I. And I've got letter I on the board now, whenever you're ready for that. Anyone have any questions on what we've done so far? Feeling okay? Take a minute, make sure you have this. Yeah,
How'd you, well, I know how you got it, but like, how'd you figure that one out, like 64, like to the base, like, how did you know this sense?
so A, I've had a lot more math class than you. B, we just did 32 was equal to 2 to the 5th.
Oh.
And if I do 32 times 2, I get 64.
Bryce, do you wanna just,
You also you can use your calculator in this. When I say no calculator, I mean like, don't like plug it in or set them equal to each other. Like this is where I do not want you to go like y1 and y2 and graph like that. But if you're like, I know 62 is 2 to some power, I just don't know what it is, you can use your calculator. We will talk about calculator rules for the test next week. I just am not sure if we're gonna do 2 different sections or if we're just gonna do it all together, so it's all graphing calculator. If it's all together and you can have your graphing calculator for all of it, I still expect like this level of work on a problem like this. Does that make sense? And I will probably still separate it where I'm like, these are like, I don't wanna say non-calculated, but I'd be like, you would solve these without using a graphing calculator, and then these would be ones that you definitely need a graphing calculator for, just so you can kind of get your brain together on like, when should I be using it, when should I not? Right,
Will the final be like that too?
the final will definitely be 2 different parts. We will talk more about the final the week after, which is why I have like a whole week and lots of days of review to talk about it. But basically, the first part's the no graphing calculator, and it's just like 30 multiple choice. And then the second part is yes graphing calculator, and it's like a normal test, like open answers, solve this, show your work. Yeah, GT.
How do you even?
If you were to do this on a graphing calculator, you would just graph one of them, so you'd put like this into y1. And then you put this into y2 and you find where they intersect. Mhm. But as you're seeing, like we've done enough of these by hand, you're just like, I don't even think that that's helpful, or that's not where my brain would go. Okay, let's jump to the next part. This next part is actually like stuff that we've done already before, so these next ones all have logs in them. And I did a couple easy ones at the beginning because they help us remember and help us keep like the right form as we solve the rest of these. These are just using our log rolls to solve. So as we look at this, I'm gonna have log base 7 of 49 equals x. So when I log roll it, I go 7 raised to the x equals 49. Well, we know what that is. 2. Similar for the next one. This time my x is in a different spot, but we still log roll. 2 to the 3rd equals x. 2 to the 3 equals x, and what is 2 to the 3rd? 8. We already learned this, right? What we're about to do is kind of add a little extra step that we hadn't learned yet, but it's the exact same process of what we're doing right now. We're still gonna log roll. So if you look at the next one, it's not just x by itself, it's got x plus 2. We're gonna let that sit, but we're still gonna log roll like normal. 4 raised to the 2nd equals x plus 2. Now that it's written like this, we can solve that, right? What is 4 squared? 16 equals x plus 2. Can you get x by itself? Yeah, minus 2. X equals 14. Now, one thing I do want you to check here is if you get a negative number and it makes what's inside my parentheses negative, that's a problem and that cannot be a solution. Now here, 14 plus 2, that's definitely not a negative. That's totally fine. That's a positive. So we don't have to worry about anything. but there will be one later on that we will have to worry about. Okay. All right, let's do the same thing on the next one. Log roll that. What do I get when I log roll? Good. Good. Like that looks like an 8 to you. Let's pretend it's a 3. It'll just make the answer a little bit better. 3 squared equals 1 minus x. We know 3 squared is 9. Minus 1 from both sides. Divide by -1. -8 equals x. Now, you may say, oh, we've got a negative. This is what we were just talking about. Well, let's plug it in. If we do 1 minus -8, what's that going to give us? It's going to be a positive, right? 1 plus 8, which is going to be 9. We're allowed to have any positive number in that log, so that's totally fine. Even though we've got a negative number, it doesn't make my problem negative, so that is okay. Okay. All right. We got one more line like this. I've got 2 times log base 4 of x plus 1 equals 4. Now, if it's not just log by itself, you got to move everything else over to the other side. So I'm going to divide by 2 on both sides. We can make it the exponent. That's going to make it a lot harder later on. So when there's a number on that side of the equal sign, I always like to divide just to make it a little simpler. So I have divide by that and I get 4. Oh, no, never mind. I'll go log base 4 of x plus 1 is equal to 2. And now when I log roll, I get 4 to the second equals x plus 1. Which again makes this a little easier because if we had 4 to the 4th and we had x plus 1 squared, that would just be a lot harder. So we're just going to leave it as is. Now 4 squared is 16. 16 equals x plus 1 minus that 1 from both sides, 15 equals x. Everybody doing okay? One more like this. You got to move everything on this one. Move that 6 and move that 3, that -3. So I get -3 log base 6 of 4 plus x equals -6. And then again, I divide by that -3 just to make it easier. Log base 6 of 4 plus x equals 2. And then I'll log roll. 6 squared equals 4 plus 2. Or 4 plus x, excuse me, I don't know why I said 4 plus 2. 6 squared is 36, and when I get x all by itself by minusing 4, we get 32 equals x. Anybody questions yet? Okay, we're gonna skip ahead to number 3, so I think I already previewed that, but if I didn't, go ahead and skip to the next part. We're skipping number 3 or number 2 for right now, because it's just a slightly different movement. I just want to keep this log in our head since we're doing really well with it. These first 3 are actually just like what we just did. Do you think you can try these first 3 on your own? Again, get everything but the log away, log roll, and then solve. I'll do it silently if you want to watch along with me.
Wait.
I got a fraction here and I made it when I minus 2 from both sides, 1/6 minus 2 is negative 11/6. It's the same thing as -2. And I just got like denominator so I could minus those fractions. Yep, we are gonna use E. So on this next one, I'm gonna add 2 to both sides. Divide by 3. ln x is equal to 2. Like Denia asked, we're gonna put that E as my base, and then we'll log roll that. And truly, that's the best answer. E squared equals x, that's good enough. Don't need anything more or less different than that. You okay?
Yeah, okay. Cause I thought that X was like X minus, it's not.
We have parentheses sometimes, we don't have parentheses sometimes. Assume that if it's not parentheses, it's not part of the log. All right, once you've done letter B, go try letter C, but I think you'll need me for D and E and F. Okay, I'm gonna move to letter C. Letter C is a lot like letter A, where I got another weird fraction. If you want to use a decimal, that's totally fine. I like challenging to myself to do a fraction if I can. If you do a decimal, it's gonna be negative 0.99. And while that negative might stress us out, don't worry, because if I were to plug that in, it's still a number that's smaller than 1. So if I have this negative number that's smaller than 1 plus 1, it will still end up being a positive number. Okay, we just have 3 more problems. Are you guys ready to get them? Okay, last 3 problems. Oh, Millie.
Why did you put the 1 over there?
Why'd I put?
Oh.
Mhm. Great question. Anything else, or should I move on? Okay. The next one's so much similar. It's just a lot like what we were just doing. The only problem is we've got 2 logs on the left side. Could you combine those 2 logs to 1 log?
Yeah.
Yeah, doing what? Multiplying. Why are we multiplying? Because their bases are the same and because it's addition. So we've got log of x times x minus 3 equals 1. Okay, now that I have it as a log, 1 log by itself, then I'm gonna do my log roll. Millie. Yeah. What's my base here? 10. And then I'm gonna roll 10 to the first equals x times x minus 3. Now I'm gonna distribute that x times x minus 3 now, and I get x squared minus 3x. And I'm gonna do 10 to the first, which is just 10. Now, contrary to popular belief, I feel like every time I get a test, somebody does something crazy when we solve these. This is a quadratic, which means everything needs to go to one side. So you need to move everything to one side. I just move the 10 to the other side because it's the only one by itself. And now it's our turn to either factor or quadratic formula it. I think this is a pretty easy factor problem. What do you guys think? What would this be if I factor it?
8 to
X minus 5, X plus 2, which makes my answers what?
Negative 5, and 8 positive 5, negative 2.
Negative, positive 5, negative 2, good. Now, this is the one case where I told you we have to be cautious, we need to check our answers. If I put positive 5 or negative 2 into my beginning, would it make one of my things negative? Yeah, which one?
Negative 2.
Negative 2, so that does not count as our answer, 5 is our only answer there. Okay.
Can you explain that again?
We have extraneous solutions here, so if you solve and you get a number that when plugged back in. Would make it that we're doing log of a negative number, we can't do that. I mean, we could plug in the calculator and I'd show you that it just says error, but if you remember even like a long time ago when we did our BFF graphs. Do you remember that LN was the graph that like had a vertical asymptote here and it just went like that sideways? See how there's no negative numbers? So basic logs cannot have any negative numbers. So we need to make sure if we plug a number in, it's not gonna make it negative. All right, the last two are very similar and they're a lot like letter D, but there's a lot more logs here, right? Let's combine the two that are on the same side. So let's combine these two. What am I gonna combine them with?
Oh, division.
Division. So I got log base 7 of 2x divided by 3. And that's gonna equal log base 7 of 5. Now, do you remember what happens when we have logs on each side of the equations? They cancel out. They just cancel each other out. They have to be the same thing. Whatever we're doing the log of has to equal each other on both sides. So we can just get rid of the logs and say, okay, 2x over 3 is equal to 5. And we're just gonna solve that. Multiply by 3 on both sides. We get 2x equals 15 and then divide by 2 and x equals 7.5. That only happens, the log only goes away because I have 2 of them. Together they cancel. If you just have 1, you have to do your log roll, but 2 of them cancel. Okay, last one. How am I gonna combine the 2 logs on the left side? Multiply log base 3 of 4x. X times 4 is just 4x. And then log base 3 of x minus 2. What do I get to do next? Cancel. And so we now just have 4x is equal to x minus 2. So we're gonna minus x from both sides, so I get 3x equals negative 2. And then we'll divide by 3 and we'll get x equals negative 2/3. All right, that's all I want to do today. Good job, guys.